Hey everyone, back again for another segment of Ask an AE. And today we're going to be going over a question from Matt Maher from Lincoln Tech Indy. And Matt was wondering how to handle stock models and stock model operations in part files. So in this example, we're going to be going over the most common industry scenario, which is probably a single part scenario, multiple setup. Stock models get much more complex than that, but this kind of covers the general use cases. And we'll talk about stock models versus stock setup and when and why you would go after setting up each of those. So let's dive into Mastercam and take a look. What we've got open now is a bottle opener that we actually machined at several H-Tech Americas events over the past couple of years. And you can find this exact file on our tech exchange. That's mastercam.com/tech-exchange. And you can log in and download this. And what we're going to demonstrate here is a very typical single part multi-setup process flow utilizing stock models and how basically how we teach it as industry practice. So let's examine the different options for utilizing stock in a Mastercam program and which is useful for what. So over here in the toolpath properties group for the machine, you have stock setup. And if we open that up, this is what we get. This is kind of the old school stock setup page. And we could define a rectangular shape and select bounding box, and we could make a bounding box out of this part. And we could even click on the faces and kind of interactively drag the stock around. And this sets up one specific stock shape within stock setup. We could also use a solid or a mesh at this stage, and we define a plane that the stock is located in. So this is basically necessary if you are in a lathe environment. You have to define initial stock for the in-process stock model for lathe and for lathe toolpaths to function properly. However, it's not required for mill, and the typical workflow that I teach does not even include this stock setup page at all. So actually, before I continue on, let me just say stock setup, rectangular shape, and I'll define a piece of stock here. Up on the toolpaths tree, you have 3 buttons under stock. You have stock shading, stock display, and stock model with a drop down and some other options. But these 3 are the ones I'm going to cover. So the left 2, stock shading and stock display, are basically visual options to toggle on and off whatever you set up in stock setup. So I mentioned that I don't use stock setup, so these would be turned off. And the way I would start a model, any part file, is to basically draw my stock as a solid. So here I've got level 2, and I've drawn my stock as a solid body rectangle representing what I'm going to purchase and cut these bottle openers out of. Once I've done that, I will insert a stock model. So when you click on this, it inserts an operation into the toolpath tree. And this is something you can leverage as part of your toolpath, your flow programming. And within stock model, when I open it up, I can name it. So I'll give this a name of op1 initial stock. Then I have this checkbox, and I can choose a stock plane. So in this case, it came up with op1, which is a plane in my planes manager. But for 99% of the applications of stock model, you're going to uncheck that checkbox. And we'll go over this in a second video. But basically what this checkbox is doing is when you turn this on, it's applying a plane transformation to your stock shape from whatever your stock shape was set up in to the plane that you specify. So this isn't useful for us in our specific workflow where we've got a single part, multiple setups, but it would be useful if we had something like a tombstone and we're moving the part and the stock from face to face in the tombstone and chasing it around the tombstone for multiple setups. So here I'm going to choose a model for the initial stock shape. I'll choose that rectangle that was on level 2. And if I look in here, I can also define a starting color for the stock. So maybe I'll make it blue. And this will make more sense as we continue on with stock models. But colors is something that should be very highly utilized if you're trying to pick out what the toolpaths are doing. Within source operations, well, there's no toolpath operations created yet, so I can't apply any. But I could click on whatever ones I wanted to apply to essentially subtract that material from the stock model. Over here we have a path tolerance. That's the tolerance that is taken into account as we drive along whatever our toolpath shape is. Our tool shape tolerance, which determines how closely we model the tool when we do this stock model. And then we have the other really important checkbox here, which is mill flutes only. So when this is off, when this is not checked, we calculate the stock model including flutes, shank, shoulder, and holder. So if you have an operation where the holder clips through a clamp or a piece of remaining stock and you didn't notice, that would actually correctly remove the stock as if the holder had plowed through it. However, that takes more calculation time. So if you're pretty confident in what you've done to set up the paths, you can turn on this mill flutes only checkbox, which basically calculates only against the actual cutting flutes of the tool. So it won't show you a giant trench or gouge that your holder made if you tipped your holder too far on a 5-axis machine per se. So this is a little bit more dangerous if you haven't taken the time to properly set up your tool paths, but it saves a massive amount of calculation time, especially on complex finishing paths. So I typically leave that checked and just program a little more carefully. So I'll click OK. And all that we just did was to generate this stock model. So if I actually go and turn off my level 2 solid, you can see that when I click on the stock model, I get the image of what the stock looks like at that stage. So again, this is my standard workflow. The very first operation in almost every mill part file of mine is a stock model generated at the initial shape. And now we're going to leverage that. So let me make sure I'm set up on my Op1 plane, and I'm going to make an OptiRough. And I'll just say I want to OptiRough the whole part. I'm going to stay within this wireframe rectangle here. I'll use a 1/2-inch tool. And now I'll add a stock reference. So I'll turn on rest material, and I'll say the stock rest material is coming from one other operation. And then I just reference that stock model I just created. So I'm pointing the toolpath at exactly the stock I know is there at the time I create the toolpath. So I'll click OK and let that generate. And here's what we got. So we intelligently come from air and we machine all of that stock. So the next thing I could do is create another stock model. I could say this is Op1 after roughing. And for the initial stock shape, I could say I'm starting with the initial stock and I'm cutting this stock model with operation 2, my OptiRest. And now I'll actually change the color here too. I'll change it to like a pink color. I'll say OK, and let's generate that stock. And that's what I get. So I see the pink is everywhere my 1/2-inch tool cut. And that's maybe not that useful right now because I've only cut it with one operation and one tool, but it's going to become useful in the next step. So now I've got a reference of where my stock is after my first roughing operation. Maybe now I want to come in and rest rough because you can see my big tool didn't get the hook in this area and it didn't clean up some of the corner areas. So what I like to do actually, since I've already set up my geometry, my heights and everything in my first OptiRough rough typically, I'll right click and drag this down and I'll say copy after. So I'll copy the whole OptiRough operation. And then I'll simply swap out my tool for a smaller tool. Maybe I'll go an 1/8 inch bullnose tool. And I'll just swap out my stock as well. And I'll reference the Op1 after roughing. But I'll keep all my other geometry, selection, depths, step over parameters exactly the same, and I'll leverage all that to quickly create rest roughing operations that intelligently grab the rest of the stock. So you can see here, we're zooming around and all we're getting is the hook areas and the corner areas that we couldn't dig out. And we've got that pocket too, we've got the inside. So that did an awesome rest roughing job, and that was virtually no effort to create that. So now we could create one more stock model, and we'll call it Op1 Finish. We'll set our stock model reference to after roughing. We'll cut it with the Op4 rest roughing with that small tool. And we'll change the stock color that we use when it gets cut, and maybe we'll just change this to a bright green. And we'll hit OK, and let's generate that. So here we can see all the green is the areas where that rest roughing tool actually touched the part and cleaned things up. So we've got a good idea of what tool touched which areas just visually with those color changes, and now we've got a good reference of what our stock looked like. So let's say that's side one of this bottle opener done. Let's create side two. So we'll do the stock flip in the vise. So I'll make a new toolpath group and I'll call this Op2. So we've got a couple choices as to how we set up Op2 now. So what I call this is like a single part, multiple setup flow here. So even if this was, say, a Haas VF2 with two vices sitting right next to each other, and one vice was Op1 and one vice is Op2, I'm not going to physically draw two vices side by side here. What I do is I take my part geometry, and I leave it where it is. I don't copy the part and transform it and physically flip it over in this model. What I do instead is I transform the fixturing around the part geometry. So here's my Op2 fixturing. So I only have one solid body of the actual part in my file. And you can see if I toggled on the Kurt Vice for Op1, they're stacked upside down on top of each other. So what are the advantages to doing this? Well, what we've got in planes here is we've got an Op1 plane and an Op2 plane with different offsets. So this is a G54 offset and this is a G55. So we can still set this up as two side-by-side vices in the VF2 and just use different offsets. However, since we left the part geometry alone and we transformed the vices around the part, I only have one set of geometry that represents that final part. So let's say we change this bottle opener. Maybe we make the pocket a little bigger. We change the hook shape so the caps come off the bottles easier. If we had physically copied our bottle opener and drew the twin vice setup here, we would have had to make that change in two locations. So in other words, we no longer have one master set of geometry driving all of these tool paths. We have two, and we need to selectively remember what paths affect what and what geometry is being used, and it gets to be a little overwhelming. So this flow where you have one master set of geometry and you build the fixturing around it in whatever orientation is necessary is really, really good practice for single part flow. So now we've got an Op2 plane with a G55, and we've got our Op2 fixturing. And bonus, since we used this single part flow, our number 5 stock model here, Op1 Finish, is exactly what we want to cut now. So I could launch right into another OptiRough, and I'll select all this as drive geometry again. And for toolpath control, I'll use my wireframe box as containment again. And I'll use my 1/2 inch end mill. And my stock is going to be Op5, which was the Op1 finish that I created. And then maybe the last thing I'll do is set a maximum depth here. And I'll grab the top of the vice jaws, and maybe I'll go 5 thou above that, just so I don't cut my soft jaws. And I'll say OK. So here's my operation 2. I stay off the jaws, and I correctly cut all of that remaining stock. So this is where the power of this stock model comes in. Let's say at this stage in the game, I have to change the size of my stock. I ordered the stock. When it came in, it was bigger than the company said it was going to be. Or maybe I screwed up at the saw and cut them too big. So I go to my Op1 stock, and okay, they're a 1/2 inch wider. So I go model prep, push pull, and I pull that solid body on level 2 out by 1/2 inch. And maybe I screwed up on the saw, remember? So I'll pull the length of the bar out 1 inch. That's a big screw up on the saw, but maybe I wasn't looking. So when I did that, because all of my stock model operations reference this solid body, and all of my toolpath operations reference stock model operations, these automatically went dirty because they know the stock has been adjusted. So let's just regenerate all of that. I'll turn off Op1 stock entirely. And let's go back to the first setup because that's a little easier to see. So now in setup 1, I've automatically adjusted the entire program for the stock changes. And I did not have to lift a finger. I didn't have to reselect any geometry in any of those operations. It's just automatically referencing exactly what I want. So in this example, what we did here was we were basically creating a stock model every other operation, right? We do roughing, then we do a stock model, then we'd rest rough off that, and then another stock model. But we don't have to do that. And as industry practice, it's often best not to create stock models until you need to. So let's take these concepts and look at a more complicated file and see how this plays out across 50, 60 toolpaths on an actual complex part. Here we have a Formula SAE upright, a suspension component for a Formula SAE race car. And this is a fairly complex model, but we're using the same kind of concepts and methodology that we just introduced in the bottle opener part, in that this is a single piece of geometry and we transform the fixturing around the model as we do our different setups. So here we have the first operation is a stock model, just as I was alluding to in the last part. And this represents our prepped stock that's bolted down to the fixture plate that will eventually become the upright. And notice here we've got 3 operations before we see the next stock model in the tree. So we have a facing, we have an OptiRough that does the outside, and then we have a second OptiRough with some different parameters that does the inside. And then we have a stock model that generates a resultant of all 3. So because these are all independent operations that didn't affect the stock that the next operation would need to know about to cut, we didn't have to generate a stock model until we were all done with all 3 of those operations. So next we go to the next OptiRough with some side cutting, and then we do 1 more stock model, and then we do another 3 OptiRoughs from different directions, and then we have another stock model. So the intelligence here is that we're only generating a stock model when we need to know when stock is left to continue on with a smarter path. So you notice down at the bottom here, we've got like some parallel inside finish passes and a deburr op that's breaking the edges here. We don't need to generate a stock model that shows what those operations do, because the end result, the end goal of creating these stock models is to leverage them to create efficient machining motion, cut down on air cuts, intelligently stay in the cut and remove only the material that's left. So we pick and choose when we want to create these stock models to leverage them to make our program smarter. And that's the real power of using these models in process. You have the choice whether you want to create a new model to reference or not, and when you do so. You know, these contours here that finish up the last couple of thousandths off of these face profiles, that will never be useful to reference for another finish operation or another roughing operation. So we never have to calculate a stock model against them. And that's the choice we make as a programmer to intelligently build this stock reference into our programs. So that was quite an extensive look at how we process single part multi-operation flows with stock models. There's a whole other side of stock models that we didn't touch upon that take use of this transform box to basically move parts around in setups. And that's something we'll go over in an entirely separate video discussing methods of transferring stock around fixturing or transferring stock in space. And that's a little more complicated, and basically you don't want to do that unless you are forced to by the type of part or the type of fixturing or machine you're working on. So hopefully you got some good info out of this video. If you need more information or more practical examples on how to set up something like multiple stock models, multiple body flips, and maintaining references between like a dual vise setup, we have a really good example on our Tech Exchange of a bottle opener part that we actually ran at H-Tech 2018 in a twin vise setup on a Haas VF2. And it shows how to track that stock in between those setups and manage it properly if you need to reinforce this with a more practical example. So, as always, thank you for teaching with Mastercam, and I'll catch you next time.